So hello guys, Ram Ram. This DSA problem was asked for a CTC of 75 lakhs in Salesforce software engineer interview. Can you solve it? Let's check. So guys, I'm very happy to announce that my student Vivek Haldar has cracked a software engineering internship at Amazon and Google yesterday. So congratulations to him. So hello guys, with the name of God Ram Ram. This problem was asked for a CTC of 75 lakhs in a Salesforce SD interview for a senior engineer role. Okay. So array U is given to us and we are allowed to remove elements from the start or back of this array one at a time and add those elements to the start or back of the main array. Once everything is done, you can do at most M operations like this. Once you have done them optimally, tell the maximum subarray sum you can get in the main array after doing this. Now, this is a very hard unseen DSA interview problem. For OA/interview of top tech companies, please prepare hard unseen DSA plus OA plus CP problems and stop relying on easy, medium, standard DSA problems based on standard DSA patterns and standard influencer DSA sheets. Out of the box thinking is needed in general. So if you're someone who needs one-to-one mentoring plus day live training for DSA OECP, along with top product based companies direct job referrals, then you can check out the November cohort. Now guys, this problem is very difficult, so there are some prerequisites. So let me talk about the prerequisite. Also, congratulations to my student Vivek Haldar. He has cracked the Amazon and Google internship yesterday, so we are very happy with him. His attendance is very high in our day life training, and I kept him motivated regularly via my one-to-one mentoring and referral support. Now, I want you guys to listen to me very carefully. Referral support is one of the most important parts of the program, and I kept him motivated by again and again telling him not to give up in many different ways. Okay, one of my student 2 3 days back has cracked like off campus 25 LPA programmer analyst offer from Amazon. You guys can check that out as well. Guys, you need to complete this prerequisite course. It will change your life. If you have a problem of not being able to improve at DSA, not being able to solve hard unseen questions, just do this course in 5 to 10 days and you will see the change. Okay, it's a free course. So, guys, for this session, which I am conducting, the problem is so difficult that you need to complete all these hashing sessions, and mainly you need to complete session number 18, because here in session number 18, I have taught a very different way of visualizing Kadane's algorithm via prefix and suffix sums. Okay. So if you don't know those things, you will not understand what I'm trying to teach in today's session. Okay. So you guys need to complete these things. Okay. This session, then session number 17. There are many more important sessions. You need to complete them till 20. Okay. Very important sessions are there for you. So once you have done all that, now let's come. So guys, you need to know some basic things like what is the prefix sum array. Before that, let's talk about the actual question. So they are saying that let's say U array is given to you like this, 2 comma 3 comma 5, and let's say the main array is given to you like this, 5 8 and -1. For now, I will be solving the easy version. The in easy version, we can do any number of operations. We can do any number of operation, guys. Okay, but in the hard version we can do at most M operations. Okay, so if you want the video recording of the hard version, you can let me know in the comments. I will add the link to its recording in the description of the video. First, you need to understand the easy version, or else you will not understand the hard version. So what are we doing here? Ram Ram. In every ingoing and outgoing breath, you have to take the name of God, Ram Ram, like this. So you can attain the highest in this life, which is moksha and amarlok. Now, going back to the problem, you can, in one operation, you can either select the first element of array U or you can select the last element of array. You remove them and put them either at the start of the main array or put it at the end of the main array. So these are the four options at the start. So let's start doing the operations. Initially the array was 2, 3, 5, right? Let's say I remove 2 and I put 2 at the start. So now the main array is looking like this. Now the U array is 3 comma 5. Now let's take the last element of 5 and put it at the start. So now the main array, like 5 has been removed here and 5 comes here. Now only 3 is there in the main array. So now let's remove 3 and put it at the start. I am putting it all at the start of the main array only. I could have put it at the back, but I'm putting it at the start. So now the main array looks like this. 3, 5, 2, 5, 5, 8, minus 1. Now in this main array, what is the largest subarray sum? The largest subarray sum is this one. So the final answer will be 3 plus 5, 8, 5, 5, 10, 18, 19, 20, 18. 18 is the maximum subarray sum which you can get. 5, 5, 10. Okay, not 18, I think 28. 5, 5, 10, this is 8. This is 18. And 5, 3, 8, 9, 10, 28. 28. This is the maximum subarray sum in the final array. So guys, can you see how hard the question is? You have to optimally decide how will you distribute the numbers in the array U such that the final subarray sum of the main array is maximum. Like a final main array will be created, but how will you know that the main array is created in such a way so that whatever is the maximum sum subarray in that Kadane's sum is maximum? This is a very complicated problem. Nothing comes to our mind. So you need to have a little bit of prerequisites, and the first prerequisite is you need to know what is the prefix array. Guys, if you do not know these concepts, now don't worry. Please complete this prerequisite course, hashing part. Complete it from session 0 to session 20 and you will understand whatever I am saying in this video. Because this video is not for beginners in DSA. Okay, you need to have intermediate level or above that. Prefix array. So whatever array, like main array I give you, Ram Ram. Let's say I give you this array 5, 3, 8, minus 1, 10. So the prefix array is nothing but a congruent array, like a corresponding array created on the main array. Okay, so let's say this is B of I. Like this array is B and this is, let's say, B of I. So prefix array P of I will just store the sum of the elements from index 1 to index I. This thing you need to remember. This thing you need to remember. How it works, you can watch those prerequisites video, you will understand. So here the prefix sum is 5. Sum of this much part is what? 5. Sum of this much part is, look, not that one, sorry, 5 plus 3 is 8, but not this. Sum of this much part is what? 8. What is the sum of this much part? 8 plus 8, well, it's 16. What is the sum of this much part? 16 minus 1, well, it is 15. What is the sum of this much part? 15 plus 10, well, it is 25. So guys, that's it. This is index 1, index 2, index 3, index 4, index 5. So P of 5 is telling you the sum of elements from index 1 to 5 in the B array. Whatever was the sum of all this, it's here. P of 4 will tell you the sum of the first 4 elements. So you can do this thing, right? So it's given here, Pi equal to sum of from 1 to I. You can just run one for loop and you can write like sum of the first I numbers is nothing but the sum of the first I minus 1 numbers which you have already calculated, because first you were at index I minus 1, then you came at the index I. So P of I equal to P of I minus 1 plus B of I. That's it. Now guys, prefix sum array you can calculate. Guys, there is one more type of array. If you normally do Kadane's algorithm, you cannot solve this question if you do it from the standard DSA log over driver sheets. No, 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 no. You need to understand the deeper essence of the Kadane algorithm, which people generally don't know. So for that, I have taught it in the prerequisite course in the hashing part. But guys, max underscore P of I is very, very important. This thing you cannot skip. Max P of I is another array which will tell us the maximum subarray sum ending at index I, forcefully including the element I. So what does this mean? Maximum subarray sum ending at index I. Maximum subarray sum ending at index I. So, like the formula for this is very simple. You can see here the maximum sub-array sum ending at index I is nothing but only two options are there. Either you include the last element and call it as the day that okay, we are only considering this sub-array of one of size 1, or you can take the last element plus the best maximum subarray sum ending at index I minus 1. So using this formula you can calculate max p of I. Okay, and if you take maximum of all the elements of the max p array, then this is the maximum subarray sum. So this concept I'll try to explain you one more time, baby. So let's take some example. Let's say let me explain you what max p array is doing. 5, 8, minus 10, minus 20, 3, 8, 11. Let's decookify, guys. Let's decookify. So 3, 8, let's call it as, I don't like 11. Let's use 3, 8, 11. Okay. Let's use 8. Okay. Or let's use 7. Let's use 10. Now, guys, listen to me very carefully. Okay. This is the array given to you. So for each index I, can you know what, like if you're trying to calculate, this is the B array. Now what will the max P array corresponding max P array? Max P array should tell you the largest subarray sum ending at that index. Okay. So the largest subarray sum ending at this index is 5, 5. Largest subarray sum ending at this index is 5, comma 8, 13. It looks like prefix sum, but it is not exactly prefix sum. What is the largest subarray sum ending at this index? There are three subarrays ending this. Let's say this is the index I. There are three subarrays ending at index I. One is minus 10, another is 8 minus 10, another is 5 8 minus 10. Guys, please make sure you like, share, and subscribe. So I feel motivated to make regular videos for you people. In every 2 days, I try to post videos here so you guys can master DSA or ACP. So why are you not doing the work? Please do the work. And also comment your codes in the Google chat. Not Google chat, like I take so many Google meets, I have the habit of saying Google chat. Make sure you comment in the YouTube video description. So guys, these are the three subarrays ending at index I: minus 10, 8 minus 10, 5 8 minus 10. Which is having the maximum sum? Minus 10, 8 minus 10, minus 2, 5 minus 2, 3. Guys, this one is the best. 5 plus 8 minus 10 is the maximum subarray sum ending at index I. So 3 is the answer. Here, what will be the answer? So, this is minus 20, right? This is minus 20. So, in this case, I think minus 20 and minus 10 will be minus 30. Okay, okay, okay. This much part sum is plus 3, right? So, plus 3 minus 20 minus 17. So, for this index I, the largest subarray sum is this only, ending at this index I, which is minus 17. If this was your I, what would be the largest subarray sum? There are so many options, right? Either it can be 3. This is also a subarray ending at index I, or minus 20 comma 3, or minus 10 minus 23, or 8 minus 10. All these subarrays are ending at index I where the number is last number is 3, or 5 8 minus 10 minus 23. Which option is the best? All options are bad, only the first option is good. So for this index I, only this element is a good, like maximum subarray sum ending at index I. So here it will be 3. For this index I, this is the maximum subarray sum 10 and 3 ending at this index I, 13. And for here 13 plus 8. If this is your index I, this is the maximum subarray sum which is valid, 13 plus 8, 21. Ram Ram. Okay. So 3, 13, 21. So you guys have understood these things, right? So max p array you have to calculate. Max p array basically tells you these things, okay? Like this 3, let me write here. This is 3, okay. Ram Ram. This is 3 and then this is 13 and this is 21. So these things are done, these things are clear. So max p array tells you what? The maximum subarray sum ending at index I. If you take, see, if you take max of all of them, if you take max of all of them, max of all of them is what? 21. So 21 is the Kadane sum of the array. 21, basically this is the maximum subarray sum in the whole array. Why? Because whatever is the maximum subarray sum, it can either end at index 1 or 2 or 3 or 4 or 5 or 6 or 7. If you take max of all of them, maximum subarray sum ending at index 1, 2, 3, 4, 5, 6, 7, then guys it's totally clear that one of them will be the Kadane sum, maximum subarray sum. So that's it. Now we can go to the actual question. So guys, please know, if you want the video recording of the version where we are doing only M operations, please do one thing. Write it in the comments that you want for the harder version also. For easy version, you can do any number of operations. So this question is given to you. Now, how will you analyze it, baby? Array U is given. You are allowed to remove elements from the start or back of this array one at a time, and add those elements to the start or back of the main array. You can do any number of operations you want. Tell the maximum subarray sum you can get in the main array after the options are done optimally. So guys, the trick is simple. The trick is smartly put all the positive elements of U array at the left of the main array. Now, why is this trick working? See, like let's take some example from the past only. If we have, yeah, 2 3 5, okay, 3 5, okay, let's say the main array is like this: 3 minus 5 8 minus 8 minus 2 and 1, okay. And like this is not the main array, this is your U array, okay. Now let's call this as our main array. Main array looks like this: 5 8 3 minus 4 minus 5, okay. So first of all, what will be the best answer if you do no operation? If you do no operation, what will be the best answer? You will just calculate the max p array, right? For this, you want to know the maximum subarray sum in the main array, right? If you don't do any operation, main array will remain as it is, right? So what will be the main array? The maximum subarray sum ending at this location is 5. At this location, it is 5 plus 8, 13. At this location, it is 13 plus 3, 16. At this location, it is, I think, 16 minus 4 is what it buys? 12. 12 minus 5, 7. These are the maximum subarray sums. And what is the max of all of them? Max of all of them is 16. So this is the maximum subarray sum for the main array if you do zero operation. But guys, if someone tells you to do maximum, like do any number of operations and increase this Kadane sum, see, when you do no operation, you are able to get 16 as the answer. Can you increase this answer by doing some operations? Yes, you can. What you will do? All the positive numbers from you will put on the left hand side. How? 3 you will take from here, you will put here. Negative number you see, you take it and you put it here on the right hand side, minus 5. Positive number you see, like now this is the remaining URL. Let's say you pick this end number, put it at the start, 1. Minus 2 and minus 8, these negative numbers you put here. Can you see I'm putting the negative numbers on the right hand side? This 8 is left, put it at the start, 8. So now the final main array is looking like this: 8 1 3. All the positive elements of U are put here, and this is joined with the main array: 5 8 3 minus 4 minus 5. So earlier the max p array was only consisting of this red part, right? This red part. What was the maximum subarray sum? Let's say for this index I. Maximum subarray sum for this index I was 5 plus 8, 13 plus 3, 16. But now, there is another option also. Another option is what? You can take the sum of elements from index 1 to I. You can take the sum of elements from index 1 to I and add it with all the positive numbers which you have collected. 8 plus 1 plus 3, which is what? 8 plus 1 plus 3, which is what? 8 plus 1, 9 plus 3, 12. So 12 plus sum of numbers from index 1 to 3 was 16. 16 plus 12 is the new answer. 8 here, 28 is the new answer. So guys, now in this final array, if it looks like this, 8, 1, 3, 5, 8, 3, minus 4, minus 5. Now this is the maximum Kadane sum. Why did this trick work? This trick worked because I put all the positive elements from you at the left part of the main array. When you do that, it just decognifies the things. So why it is working? Let's try to think about that also. In theory, you can assume that this is your main array. Okay, this is your main array. There are many indices like this, right? For a particular index I, let's say the maximum subarray sum of index I only consists of the last three elements. Let's say this is 1, this is 1, this is 1. This is minus 3, this is minus 3. Index 1, index n. So, what will be the maximum subarray sum ending at index I if no operation is done? Only these three, right? 1 plus 1 plus 1, which is 3. So, currently max P of I is 3. Our task is to increase the value of max P of I. So, what one option you can do is, let's say U is looking like this. 2 minus 10 and then 7. Okay. The positive elements from you will put it in the start. 2 here, 7 here. Now what will happen? Max P of I, if you only consider the main array, the max P of I is 3. But. The value of max P of I will change. Another option will come for max P of I if you add 7 and 2 at the start. Now what will happen? Now max P of I is nothing but sum of numbers from 1 to 3 plus the positive numbers at the start. With eyes closed, you can add these positive numbers. Why? Because they are only going to increase your max pi because they all are positive. So, and you will have to take the elements from 1 to I also. Why? Because if you take elements from 1 to I and join with the positive elements, only then a contiguous subarray can come, which is ending at index I, which is also utilizing the positive elements you got from the U array. So now the another option is for max pi is sum of numbers from 1 to I plus the positive elements you got. So what is sum of numbers from 1 to I? It is minus 3 plus what are the positive elements you got? 7 plus 2, 9. 9 minus 3, 6. Earlier max pi was 3, now max pi is 6. So same algorithm we will use for each index I will try to maximize the max pi. Once all the positive elements are added to the left, and the maximum of all possible max p of I, once all the positive elements are added to the left, this is the final answer. Now we did a smart observation. We are putting all the negative elements on the right hand side, so it's not affecting us. Why? Because max p of I only goes from 1 to n. Max p of n only considers the best subarray sum ending at index n. It does not see what's happening after n. So you can just dump the negative values here, so the negative values don't affect you, baby. So guys, that's it. Like in the one of the codes which I wrote for you lovely people. Yeah, here I have the code. You can see that the pi array calculated, max pi array calculated. Then if I go below, you can see from index 1 to n, m, like m is the size of the main array. Either the answer can be max p of I or the sum of numbers from 1 to I, which is p of I plus the positive elements in array u, which is up. You can see all the positive elements of array u I have added in up. Ram Ram. Current question. Now guys, listen to me carefully. This is case 1. The best answer you are getting by putting all the positive elements at the start. What? But you can also put all the positive elements in the end, bro. Then what will happen? Okay. You can do this thing also, right? Minus 3, 1, 1, 1, and let's say the main U array. I call it as main, but this is U. Let's say this is the main array, right? Let's say U is 2 minus 3, and this is, let's say, 8. So what you can do is you can put this element 2 at the end here and 8 here, and this negative element here. Now in this subarray, the maximum subarray sum is this one, which is even better than the previous one. 3 plus 2, 5 plus 8, 13. So guys, the another technique is that you will calculate the suffix s of I, the suffix sums. This is your main array, right? So what is the sum of this much part? It will be stored in s of n. What is the sum of this much part? It will be stored in s of n minus 1. What is the sum of this much part? It will be stored in s of n minus 2. You can see in my code, I have done it for you lovely people. Traveling the array from backwards. From M to 1. PFO means the loop is going backward. You can see that's my template, baby. So you're going from M to 1, right? So S of I is main of I plus S of I plus 1. Similarly, as you calculated max P of I, max S of I means largest subarray sum you need to know, which is starting at particular index I. So here, let's say you know this is the main array, right? No, no, no. This is the main array, right? Okay, this is the main array. This minus 3 you are putting at the start. Okay, just making some speed. This is the main array, right? Let's calculate max S of I for each of them, which is suffix reverse direction. What is the maximum subarray sum? If your array is starting at this index, it is 1. If your array is starting at this index I, the maximum subarray sum is 2. If starting at this 3, you can see the maximum subarray sum and starting at this index I. Here, the maximum subarray sum will be minus 3 plus 3, 0. And here it will be minus 3 only. Either you take this or you take this full part. So now you know the max S of I if you only consider the main array, right? But what if you add all the positive elements at the back? Now you have 2 plus 8, 11 extra here. So for each of them, there are two options. Either you go ahead with this or some, let's say this is your index I. So sum of the elements from index I to n, or here also you can write sum of the elements from I to n plus the positive value 11. This is another option for max S of I. So for this it will be 1 plus 11. So 1 or 12. For this it will be 2 plus 12. So 2 or 14, and for this it will be 3 plus 12, 15. So you can see max of S of I, other values are coming. So 15 will end up being the best answer. That's what I think. For this minus 3, it is 0. But if you take the sum of elements from minus 3 to this main array, it is 0. So 2 plus 8, 10. So here the answer can be 0 or 10. 0 is maximum S of I if only main array is considered. But if you add positive elements at the end, then the maximum S of I will become from 0 to 10. See, all max of S of I are increasing. This is normal max of S of I minus 3 for this index I. But if you add 2 and 8 here in the end, it will become 7. Why? Because the sum of this full original array till here is minus 3. Right? Minus 3 plus 1 plus 1 plus 1. This they neutralize themselves, become 0. So minus 3 plus 2, minus 1 plus 8, 7, right? So decooknified, guys. Ram Ram. Always do Ram Ram as much as you can in your ingoing and outgoing breath like this. So you can get moksha and amar lok. Now guys, these things are clear. So guys, same thing, case 1, case 2 you will solve. Case 1 where all the positive elements are put at the front, and then the case 2 where the positive elements are put at the back. Now this much knowledge you need just to solve the easy version. If you want the video for the hard version, you can let me know in the comments. I will attach its recording link. Hopefully you guys enjoyed it and learned about prefix array, suffix array, the greedy plus minus distribution which we can do, and max of s of I and max of p of I. You can think a little bit for the harder version which was actually asked in the interview, that you can only do at most m operations. Here we are doing g number of operations, where g is the size of the u array. But in the question they have given a m, you can only do at most m operations. So what will you do if the number of operations are constrained? You can use some trick, structuring and constraining trick, like there are only few configurations possible, right? You can try to find max of all of them. Anyways, ram ram.